You're listening to Arsenal for Democracy, episode 380, recorded on Sunday, June 6th, 2021. I'm your host, Bill Humphrey. Joining me on the line from Idaho is Rachel. Hello, Rachel.
Hi, Bill.
And joining me on the line from New York City is Kelley. Hi, Kelley.
Hello, Bill. Hi, Rachel.
This week, we're going back further in time to the first Industrial Revolution to talk about the popularization of interchangeable parts instead of custom-built piecework. This was a key breakthrough in manufacturing processes that allowed for the rise of the so-called American system of manufacturing, broader mechanization of the emerging industrial economy, and eventually mass production assembly lines. While the concept of interchangeable parts was not invented in the United States and has a lengthy history in ancient China and proto-industrial Europe, the nascent industrial capitalist class took to it with such enthusiasm in the United States that it became most closely associated with Americans during the first Industrial Revolution era. As we'll discuss today, this early drive to mechanize was partly a result of early American capitalists having a smaller labor pool to work with compared to European or Asian counterparts, who could simply use craftsmen or grunt laborers like machines to ramp up their industry. American employers also had to compete with the lure of land ownership for men, which wasn't available in Europe. Interchangeability not only helps steer industry toward mechanization, but also the mechanization of manufacturing processes in turn allows for much more precise, standardized, repetitive production and milling of component parts, promoting interchangeability in a feedback cycle. On episode 349 in February 2021, from our bonus feed on Patreon, Rachel and I examined the spread of the piecework putting out system in the Massachusetts bootmaking industry and the transformative effect that even this step had on the production of custom boots as piecework and on the craftsmen who made them. But as we discussed then, that industry was much farther behind the curve relative to other industries in the United States, and it did not become mechanized and mass-produced until later. In the meantime, other American industries were already rapidly pushing toward mechanization via interchangeable parts and indeed, interchangeable finished products. As we will see today, the popularization of interchangeable parts is especially inseparable from the development of the American arms industry, like so many of the industrial developments we discuss on the show. And the phenomenon was sometimes called the armory practice, due to extensive early use of interchangeable parts and standardized firearms production in U.S. armories in Massachusetts and Virginia. As always, our notes and links will be available in a PDF posted with the episode at arsenalfordemocracy.com. So Kelley, I'll go to you first to talk about the arms industry and precision machining for interchangeability.
Of course. And like so much of our economy, it is just impossible to separate the arms in the mechanisms of war with the developments in the economy in this machinery process. So I'm going to take you back for a second to the 18th century, where gun making was a skilled craft. Each gun was unique. You would order a gun, and that gun would be unlike any other gun in the market, which meant because it was made by hand. And so if a piece broke, if you wanted to change a part, you just couldn't, because there were no replacement parts. This was not, IKEA. And so this process was extremely time-consuming and expensive. And like Bill said, the idea of this interchangeable parts was not unique to the United States. In fact, in the mid-19th century, a gunsmith in France, Honoré Leblanc, came up with the idea to make guns from standardized patterns. And Thomas Jefferson, on one of his trips to France, even went to Leblanc's workshop and was very impressed by the idea. But like Bill referred to, there were enough gunsmiths, enough labor in Europe at the time that this idea didn't quite catch on. There wasn't a need for this sort of efficiency. But then if you come back to the U.S. in 1797, Congress voted to prepare the nation for war with France. And so in order to go to war with France, and part of this preparation was acquiring the tools of war, one of which, of course, in 1797 was the musket. So they needed thousands and thousands more muskets. And so in 1798, Eli Whitney, we know his name, of course, from the cotton gin and from being a key American inventor, he obtained a government contract for 10,000 muskets to be produced in 2 years, which was just extraordinarily fast at the time, given that each gun was sort of a recreation of the wheel. They were starting the process new by hand each time. So I'm going to read a quote here from a history article on interchangeable parts. By January 1801, Whitney had failed to produce a single one of the promised weapons and was called to Washington to justify his use of Treasury funds before a group that included outgoing President John Adams and Jefferson, now the president elect. As the story goes, Whitney put on a display for the group, assembling muskets before their eyes by choosing, seemingly at random, from a supply of parts he brought with him. The performance earned Whitney widespread renown and renewed federal support. It was later proven, however, that Whitney's demonstration was a fake and that he had marked the parts beforehand and they were not exactly interchangeable. Still, Whitney received credit for what Jefferson claimed was the dawn of the machine age. And so in this instance, Whitney clearly knows what he has to do. He knows there's something to be said for these interchangeable parts. He knows that's how he's going to be able to fulfill this order for the federal government. But still, by 1801, 3 years after his 2-year contract had been granted, he was not able to actually execute. Still, he knew this was the solution. He stuck with the idea, and he did finish making his 10,000 muskets using this technology. However, it was 18 years after he began this in 1798. But he was onto something, and 2 years after those 8 years, he produced another 15,000 muskets. So once he had been able to essentially make the machines that would make these parts and nail down the assembly line, there he was onto it. And so 15,000 muskets within 2 years. I'm going to hand it over to Rachel now, who has some notes on military uniforms, another example of how sort of the arms race and the military intersect with these advancements.
Right. So not only do you need lots of muskets to go to war, you need a lot of uniforms. So prior to about the Civil War, Army uniforms were very general. They had general guidelines for what was required, but they didn't really have a point source for uniforms, really. So to kind of go back to the history of the textile industry in the U.S., it didn't really get going in a mechanized industrial manner until Francis Cabot Lowell, who brought the factory system to the U.S., and he basically copied the textile mill system from Richard Arkwright's Manchester cotton mills. And so he opened the Boston Manufacturing Company in 1813 on the Charles River in Waltham, Massachusetts. And he spun and weaved cotton grown by slave labor in his factory. So this is kind of the origin of the cotton is king mindset. Wool definitely was a popular textile, but cotton just kind of grew by leaps and bounds because of this mill industry and the available cotton grown by slave labor. And although the lock-stitch sewing machine was invented in the 1830s, which did allow for ready-made garments, demand was low and most people made their own clothes. However, the Civil War created a demand for uniforms in standardized sizes made quickly for both the Confederate and Union armies. So factories expanded to meet the demand. And after the Civil War, the men liked having the convenience of ready-to-wear clothes, so manufacturers started mass-producing menswear, and then later, women's wear came later. A lot of women's wear was made to order up until this 1860s, 1870s time. And so just the convenience factor, the availability of the factories, the availability of these ready-to-wear clothes just made it the convenience factor kind of win out over having clothes made to order.
Now, Rachel, I think the most obvious parallel here that jumps to our minds is the episode that we did relatively recently on canned foods and how the Civil War created this huge demand for mass-produced standardized food rations, provided the resources to build a whole bunch of factories during the war, and then they used advertising to create a civilian consumer market after the war had ended to keep that business going. And that advertising component, as we said, is tied very closely in the Second Industrial Revolution to the canned foods industry. But as you alluded to with the mass-produced clothing, even though the technology existed to do mass-produced ready-to-wear clothing in sort of standard sizes and so forth, It didn't really become popular until after the Civil War, and I would guess that part of that is, as you said, it's the low demand in the consumer side, which you need to juice by doing consumer advertising campaigns, which, as we said, really did not become a huge phenomenon until the Second Industrial Revolution after the American Civil War. Now, one thing that's important to note here while we're talking about the arms industry and the defense industry and its role in promoting interchangeable parts in the American system of manufacturing is that again, this didn't start in the United States, but why did it become so popular in the United States as opposed to other countries that also had the ability to do this? So, remarkably, the British also used mass production of interchangeable parts for their arms industry around the same time during the Napoleonic Wars. And they were pretty successful, as Rachel is about to talk about. But for some reason, they still didn't manage to get it to proliferate into the civilian industry for decades. And you compare that to the Americans, or rather contrast that with the Americans, they were busy promoting it for both. There was often very close cooperation between military and civil industrialists, sort of sharing the technology and so forth, and figuring out how to apply it to civilian functions. And I thought that was sort of an interesting distinction that helps explain one of the reasons why it took off, although, as we'll talk about later, the other question is, why was there such a push to do that in the United States where there was not in Britain? But before we get to that, Rachel, could you talk a little bit more about some of the naval work on the British side that also contributed to the field of interchangeable parts?
Right. So as you said, during the Napoleonic Wars, it did create a huge demand. So in England, there was a demand for pulley blocks that would move sails on ships. Quoting from the Wikipedia article on interchangeable parts, mass production using interchangeable parts was first achieved in 1803 by Mark Isambard Brunel in cooperation with Henry Maudsley and Simon Goodrich, under the management of and with contributions by Brigadier General Sir Samuel Bentham, the Inspector General of Naval Works at Portsmouth Block Mills, Portsmouth Dockyard, Hampshire, England. At the time, the Napoleonic War was at its height, and the Royal Navy was in a state of expansion that required 100,000 pulley blocks to be manufactured a year. Mark Brunel, a pioneering engineer, and Maudsley, a founding father of machine tool technology, who had developed the first industrially practical screw-cutting lathe in 1800, which standardized screw thread sizes for the first time, which I just want to point out, that's huge. Having standardized screw thread sizes is really helpful for this sort of mass production. You can grab any screw, and as long as it has that standardized thread size, you can use it in your product. So Brunel and Maudsley collaborated on plans to manufacture block-making machinery. The proposal was submitted to the Admiralty, who agreed to commission his services. A total of 45 machines were required to perform 22 processes on the blocks, which could be made in 3 different sizes. The machines were almost entirely made of metal, thus improving their accuracy and durability. The machines would make markings and indentations on the blocks to ensure alignment throughout the process. And I kind of wanted to liken that to the tab A and to slot B that you see on mass-produced furniture instructions, assembly instructions. This is kind of one of the earlier iterations of that. One of the many advantages of this new method was the increase in labor productivity due to the less labor-intensive requirements of managing the machinery. Richard Beamish, assistant to Brunel's son and engineer Isambard Kingdom Brunel, wrote, "So that 10 men, by the aid of this machinery, can accomplish with uniformity, celerity, and ease what formerly required the uncertain labor of 110. And by 1808, annual production had reached 130 blocks, and some of the equipment was still in operation as late as the mid-20th century. Listeners might recall Isambard Kingdom Brunel as the builder of the ship that laid the first permanent transatlantic cable, the SS Great Eastern. And we talked about that on episode 367.
Now, Kelley, could you talk about some of the civilian applications that were happening at the same time as the early American military applications of interchangeable parts?
Absolutely. So by 1806, there were examples of this happening with with wood, specifically the mass production of interchangeable parts in the U.S. By Eli Terry, who had a contract in 1806 called the Porter Contract. This was not a government contract, but in private industry. And he was required to produce 4,000 clocks in 3 years. And just for reference, the annual average of clock production sort of per person was a dozen clocks a year. So this was pretty insane that he was going to need to produce over 1,000 clocks a year. However, Terry successfully used a milling machine with jigs and templates to produce uniform parts that could then be assembled on an assembly line by folks who were not skilled clockmakers. So he was able to fulfill that contract thanks to this technology and his advancements here. And so one of the first sort of private industry examples of the use of this technology. This technology was a little bit harder to apply with metal, like Eli Whitney had done with guns. And so the historians differ a little bit on the progression of using these milling machines with metal. But it is clear that by 1832, both Simeon North and John Hall were able to use these milling machines with metal to create parts that then required just a little bit of filing and could be used in the assembly line process. And so by the 1830s, this was folks were able to use these technologies in private industries, separate from sort of the mechanisms of war, to make products for American consumers, both with wood and with metal.
Now, let's talk about why this became associated with the Americans, as opposed to the British, who in many cases were the actual pioneers of a lot of the innovations of the Industrial Revolution. So, as I said in the intro, the early drive to mechanize was partly a result of early American capitalists having a smaller labor pool to work with, and their European counterparts, or even Asian counterparts in some cases, kind of just using people instead of machines, and that there wasn't this big available land to give out to homesteaders and yeoman farmers and that sort of thing. So you had a lot of workers who were available to fill those roles. So let's quote now from Joseph Whitworth, the English machine tool maker and British commissioner to the New York International Exhibition in 1854, on his analysis of what has come to be called the American system of manufacturing. Quote, "The American laboring classes are comparatively few in number, but this is counterbalanced by, and indeed may be one of the causes of, the eagerness by which they, American capitalists, call in the use of machinery in almost every department of industry. Wherever it can be applied as a substitute for manual labor, it is universally and willingly resorted to. It is this condition of the labor market and this eager resort to machinery wherever it can be applied, to which, under the guidance of superior education and intelligence, the remarkable prosperity of the United States is due." Now, the British had already made a big leap forward with the basic factory system. So they brought workers under one roof with the factory system, but within those factories, many of those processes continued to be done by manual labor. After all, why build an expensive machine that requires water or steam to move up and down when you can pay a huge guy to move that thing up and down instead? And the early British factories often still had workers following the whole chain of production on an item, instead of just working on one piece of that item over and over. What separates this from the putting out system is that the capitalist owners had total ownership and constant supervision over the factory production and the materials and equipment necessary to produce goods, while the workers owned none of it and supplied none of it, and the workers were themselves basically interchangeable. The Americans took this a step further by breaking down the production process into more steps divided up among the workers and standardizing everything, while also replacing more of their workers with machinery. Again, they didn't invent doing this, and in fact, the British did, as we've talked about with the Napoleonic Wars and so forth and some of the earlier technologies, but Americans adopted it much, much faster than their counterparts in Britain and continental Europe. Now, Rachel, could you give one of those specific examples of what the British had been doing well before the Americans adopted this, but again, didn't actually spread it as widely as the Americans did?
Yeah, as early as 1774, John Wilkinson, an English industrialist, invented a method for boring cannon barrels that were straight and true every time. And then he adapted this method to bore piston cylinders in the steam engines made by James Watt. This boring machine has been called the first machine tool. But yeah, like you said, it wasn't really widely adopted in Britain or continental Europe.
So there's some interesting things that happen with this process of mechanization and interchangeable parts, which, as I said, go really hand in hand and mutually reinforce each other. So mechanization of more of the brute force manual labor parts of production allowed American capitalists to hire more women, or in fact young girls and boys, to work in their factories because they could operate machinery without as much body strength. That being said, unmarried women and children also got hired in large numbers in American factories early on, regardless of technological innovations in a specific industry, because they were simply much cheaper to hire than men. Although women's wages did rise in relative terms as industrialization progressed and the demand for their labor shot up. Eventually, businesses even had to start importing female factory workers from other regions or even abroad. Now, at the peak point, women made up 30 to 40% of the pre-Civil War industrial workforce in the United States, depending on what year you're looking at and how you're calculating it. And some businesses even had a majority of their workforce as women. But even without significant capital equipment upgrades, certain industries found themselves able to hire a cheaper female workforce simply by breaking down and de-skilling the process of manual production into as many discrete repetitive tasks as possible, which interchangeable parts and pieces played a role in once again. Some industries embraced this practice so thoroughly that they ended up dividing different parts of production over entirely different factories or even different businesses, knowing that they could sell an interchangeable manufactured input to another company to produce a finished good. Which I thought that was kind of interesting because one of the big features of the second industrial revolution, as we've talked about, is not only the horizontal integration of industries, but also the vertical integration of the different parts of the supply chain. And in this case, we actually see sort of an unbundling of the verticality of the supply chain into different companies and enterprises. So you'd have a factory that just worked on making one specific part for a larger piece of something that, that was going to be a finished good. But in general, American industrialists found that it was easy to replace skilled craftsmen with unskilled women factory workers. And most of that is drawn from a paper that I read titled Women, Children, and Industrialization in the Early Republic, Evidence from the Manufacturing Censuses by Claudia Golden and Kenneth Sokoloff, published in the Journal of Economic History, December 1982. There was also a few elements of that I drew from the societal effects subsection of the article on the factory system as a whole, not just the American factory system on Wikipedia. But that's sort of the broad strokes on this particular topic. And I wanted to turn now to Kelley and then to Rachel to talk about some of the sort of big picture reflections that we both pulled out while we were all researching this topic. So Kelley, what were some of the things that you noticed or wanted to emphasize in talking about interchangeable parts in the American system of manufacturing?
Absolutely. So I just cannot help but think in this, as we go over this story and this moment in history, of all of the parallels to our current economy and the current advances in technology, which are making things more and more efficient. And so I can't help but think of all of the historical parallels between our current moment with an unparalleled increase in efficiency in this moment in history when this assembly line technology and interchangeable parts made it possible to just produce more and more and more things faster and faster and faster with fewer and fewer people. And of course, as we think about the assembly line technology, it is inseparable from the rise of consumerism, and the downfall of the skilled craftsman. You no longer needed to know how to build a clock. You just needed to know how to be like person 55 on the assembly line to put two pieces together. But I think there are certainly positives to increases in efficiency that can be harnessed by society, aren't always, but can be harnessed by society to make things better, make our world and our economy a more livable place. And like Bill referred to, and like we'll continue to talk about in episodes, I'm sure, is that the rise of this technology coincided with the end of child labor. The New England labor unions were among the first to condemn child labor in 1932, just as these assembly line technologies was more and more widespread. And so I think that as we think about our current moment in technology and in the economy, if we require a smaller and smaller workforce, which seems in many ways inevitable, how do we structure a society that supports this? Do we need fewer work hours? Should we allow people to exit the workforce in a more humane way? The end of child labor also meant that children had to be cared for and protected by their own families in their own communities. They were no longer sort of like a means to an end or could benefit their family economically, and so had to be taken care of for a longer amount of time until they were 18. And so when we think about the shrinking demand for labor, my hope is that we can think of that in an intentional way, and it doesn't result just in people being forgotten, but with the increase of efficiency, using that sort of excess to take care of the people who do choose to or allowed to exit the workforce.
I did want to clarify something that you said, Kelley, because I think it may have been a little bit unclear to the listeners. So obviously, as I said, the early rise of the interchangeable parts and very early mechanization did actually promote child labor, because then they could use children instead of grown men. But as you were saying, then a century later, or a little bit less than a century in certain industries, once the mechanization process had gotten to the point where it was actually completely replacing workers in many specific tasks, they could start eliminating child labor. And we're probably going to talk about that on an upcoming episode. There were certain specific examples where child labor declined very abruptly, not because of a regulation against it or a law against it, but rather because some machine came along that did the thing that the child worker had been doing. And to your sort of broader point in the current context, the idea here is like, and this is something that we see in this sort of early 19th century period as well, is like many countries have a choice, as they did in, whether it was the 19th century, early 19th century Britain, continental Europe, or even India in its textile industry before, or sector, I should say, before it was destroyed by British colonial policy. In some cases, they just choose to use workers and laborers in horrific conditions because they have a lot of them, and what else are those people going to do, right? And in the United States, while there was obviously also a surge in, this horrific labor for women and children and so forth, in many cases, the drive was to replace workers whenever possible with machinery, and eventually that trend led to automating away some of those jobs. I mean, the other thing is when we're talking about an assembly line, right? They didn't really have an assembly line in the early 19th century. You would kind of just have one person, work on a specific part, and then you dump it all in a bucket and then go put together the parts somewhere else. Whereas later on, you end up with things like conveyor belts and stuff like that, where you actually have a proper assembly line. And we have talked about that on some previous episodes. But again, to get back to the modern context, the question here is like, are we going to just continue to rely on, the little fingers of children in sweatshops in these economically impoverished countries where families feel like they don't have other options? Or are companies going to say, well, let's make those expensive investments in automation equipment and upgrades? One of the things that's actually been kind of a key sort of pushback from the left on certain analyses around automation and so forth is that in many cases, automation has not happened either at all or in the way that it's being represented. In many cases, you're just moving the labor somewhere where it can't be seen and then having someone connect via computer to do something. And that is not really exactly the same thing as what we're talking about here. And I think that's important to emphasize as well, right? Because again, many companies, when faced with the decision of, do I want to make an expensive investment in some piece of brand new technology to replace a worker versus can I replace one worker in one country with another worker in another country where I can pay them less and do the same function, and you just have the machine assisting the process rather than replacing the worker, many companies opt to do that. And obviously, I think you will all know that from the perspective of our show, we're not going to sit around and wait for the free market, so to speak, quote quote unquote, to magically have the invisible hand come in and replace labor or implement labor saving devices that are going to eliminate the use of child labor in sweatshops or pushing impoverished women into mills in various disadvantaged countries. Before I go to Rachel, I don't know if Kelley, if you had any further thoughts based on what I was just remarking upon there.
Yeah, thank you for clarifying, Bill. I think that all makes perfect sense to me and definitely echoes what I was trying to say, that this can be, this sort of technology can make lives in society better or not better. And so just this historical moment, I think, offers many lessons for us in using efficiency in a more humane way.
So, Rachel, I wanted to go to you now for your reflections. There were some things that we didn't really talk about textually in this episode, but are sort of like implied things hanging around in the background if you stop and think about the processes we've talked about.
Yeah, it's really serendipitous that I read this Fashionopolis book by Dana Thomas, because I think the textile industry and the fashion industry is really kind of the exemplar, the modern exemplar of mass production, and the cost of kind of the processes such as de-skilling the labor or dividing the different parts of production, because that's still what's happening today. So, for example, fashion designers in Europe will buy their fabric from another country and then make their fashion samples in a third country and then ship it back to Europe or Britain or the United States. And then from there, they contract out the creation of the clothes to yet another country. So these pieces in the supply chain are just so far apart that it's really hard to kind of organize the labor force and really push back because it is subcontracted and subcontracted and just so far flung that it's really hard to kind of even have a complete picture of what's happening. And as you said, the human labor is so cheap that it's kind of been the practice to have people be the interchangeable parts and not have a lot of automation. But I think now there's so much scrutiny on the fashion industry that there is an adoption of technology that kind of reduces the needed human labor. And I think there's also so much scrutiny on how much is getting produced. And I think there is a focus on producing less and creating less waste in the supply chain. And some of these technologies that reduce the human labor, such as like the stone washing of jeans or like the whiskering of jeans, has been done by people like putting their hands in like dangerous chemicals, but not the technology is available that automates this like wearing process. So there's fewer jobs available. We don't need those people to dip the fabric in chemicals by hand or beat the fabric by hand. But the jobs are higher quality, especially in these automated systems where mechanics and machinists really benefit. They have these higher quality, higher paying jobs, but there are fewer available. So it's really kind of that balance, like Kelley said, if we are allowing people to exit the workforce or reduce their hours, is there a guarantee that their quality of life isn't diminished too much by them working fewer hours or not having as many of these jobs available?
Now, Kelley, when you were talking earlier about those early mass production clock makers, right, and going from, every clock is a custom built clock, it's one of a kind, etc., to making, 4,000 clocks of the same design over and over and over again in a very short period of time, and then having all those parts interchangeable, I was thinking, well, if your business is only making the custom clocks, that's unfortunate for you. If your business, however, and I would imagine a lot of those craft clock makers were also doing this, is also doing repairs to clocks, well, now all of a sudden you have a big business that you can do, right? You can repair a whole bunch of clocks that are all the same design. You can be the expert guy in the area who repairs all of the thousands of clocks produced by this one particular factory and uses the replacement parts and so forth. And that's potentially helpful to your business as well. And that's just sort of another example of there are going to be some losses with some of these process changes, but there's also going to be some specific, a few people who are not the industrialists themselves, who make out very well by serving in those roles as the guy who repairs the thing using the standardized parts, or the guy who keeps the actual production machinery up and running. So that was just one other thing that I wanted to emphasize. Now, in some coming episodes, we will talk more about later uses of interchangeable parts. I know we've got one coming up on sewing machines. But listeners might also recall that we did discuss mass production assembly lines for bicycles in episode 332 in November 2020, and also the huge proliferation of mechanized farm equipment in episode 315 in July 2020. Both of those happening toward the end of the 19th century, again, as a sort of logical continuation of the process that we're describing from the first Industrial Revolution at the turn of the 18th into the 19th century. So I will leave it there for this week's episode on interchangeable parts and the American system of manufacturing from the first Industrial Revolution. Kelley, thank you so much for coming on to talk about this and helping with the research.
Yeah, thanks for having me.
And Rachel, thank you as well.
Thanks. It's always a pleasure.